Alright, before I blow these motors apart, I want to get an idea of what's going on around here. So I found my big ass cases. These are a little taller than these ones over here. So if you come off the crank snout over here, which is a good spot to come from, yeah, you're we're about 6.5 inches. Well, this one here we're 4 3/4 inches, and this one over here we're about 5.5, 5 3/8, something like that. So that's how much shorter this one is than this one. Said you're coming off a different area. Ideally, we need to be coming off the crank here, but this one don't have a crank in it, so we just have to guesstimate where we're at. So we're at 5 5 5/8 inches. This one's a little bit different style insert, so we got to kind of guess on the thickness on this one. Yeah, plus I'm not or height I can read real good. What do we got there? You're about 5 1/8. 5 1/8. This is 5/8. That's a 1/2 inch different. So this is a 1/2 inch taller than this one. And like I said, this one's 6.5, so it's over an inch taller than this tall deck one. So these are blank cases, obviously, made for whatever bore you want to make them. So how big of a bore do you want to use? You want a 5-inch bore? I think there's room to do that. Yeah, there's room for a 5-inch bore. You still got room left over. Probably do 5 1/8 bore on these. Nice small bore motor. Okay, let's flip this one around. I had some questions here that I can find out. Namely, what's the difference between an Evo motor and a shovel head, or an Evo motor and a shovel panhead motor? So this here, here's your center of your motor coming across, and if you notice this dowel pin is not centered. And also the lifter blocks, I'm not sure if the lifter blocks are centered. So, depending on the angle you look at it, if you tilt your head way back it is. This motor's not quite straight up and down, so. See, I was debating if it was on center line or not. Munchies. They stay in there for a year before I eat them. Okay, so if you put this straight up and down on the cylinder and come straight across, it looks like you're bisecting right in the middle of the lifter block. So it's centered. This motor way around here. And come across the center. It looks like it's centered, see? So this motor here center the V, center the V. Center of crank. Looks like everything's pretty well centered. Looks like this dowel pin's on center too. On this motor, if you do all that, if you go in the center of the crank, center of the dowel, yeah, it looks like it lines up with the center of the case, so it looks like it's on center. This one, the center of the crank, should be right about in the middle of this spot here. And see, everything looks like they're centered up. Close, as close as we can tell. Alright, that's kind of important because These are shovel head lifter blocks, shovel panhead, and Evo blocks have different angles. S&S makes a conversion kit that runs an Evo style block. Takes Evo lifters, goes in here, and takes an Evo cam. And then other companies use the Evo style lifter or bigger diameter lifter from Harley and still use a shovel head cam. It's all about angles coming up. So I was always told the case was different between an Evo and a shovel, and I thought that was a bunch of crap. And I still believe it's a bunch of crap because it looks like everything's on center. It's the same 45-degree V angle between the blocks. The blocks are on center. It's the same damn bolt pattern. So I don't think the case is different. I think it's just a matter of the lifter block angle is different, which means the cam is in a different phasing. And the reason this is important is because when you get this motor way the hell up here, see where the push rod angle is at? Goes right where the intake valve is. See where the exhaust one is at? It goes way the hell it skews way over here someplace. See, stock, you're like right here. We're now way over here because this angle is so far over, it kicks you way past where the push rod needs to be. The push rod needs to be up here. So the push rod should be here, yet the lifter's over here. So this angle's bad. So what I want to do is put the Evo block in here, which should have a straighter up and down push rod angle, which will make it line up with a taller motor. That's why I want to know if I can put Evo blocks in here. That also gives me the Evo lifter. And the disadvantage is I'd have to use an Evo cam, which I didn't really want to do, but yeah, whatever. I want to keep my cam cover, and I didn't want to put the smooth cam cover on that has that cone on here. It looks like crap. In S&S, want to mix a couple grinds, and none of them are worth a crap for racing. So the other option is I'd have to put a hole through the cover right here, put a boss on there, stick a seal on it, and the snout would just stick out. I'd still run a distributor, but the cam would just be turning out here. You'd have the seal, so it would work. So I might have to do something like that. Not exactly what I want to do, but yeah, whatever. The thing is, the lifter angles, the push rod angle is very bad on a shovel head. It always has been. Evo's a little bit better angle, that's why they work a little better. So there you go, there's your differences. So I think it's all interchangeable. I'll ask STD about that because they make the cases, they know. I don't know, so I don't make them. So this one here is obviously a blank. So they did some rough machining in here to give you a bolt pattern. They clearance this block out. I don't know if they didn't clearance this one, I don't know why, but whatever. So they got the insert inside of here, but that's all they left it. They did get the cases machined on this side. I think this side had bolt holes too. Nope, no bolt holes on this side. So this one was never finished made to bolt onto this case. So need to take it back to them, have them put the bolt pattern in here, I guess. Dowel them together so at least they are a matched pair. These are only partially machined, so as you can tell. They're nice and thick though. Alright, so anyway, I want to see what we had to work with. Now these deck heights here, the next problem is how tall is our boss? Oh, that thing is heavy. Okay. Like I said, I just found these cases. They've been missing for a couple of years now. Okay, so it appears that we're about 6 inches wide. And we're about 6 inches tall. So they're using a 6-inch square as their boss. Okay, this motor here runs about a 5 1/4 inch boss by almost 6 inches. So this has the same basic width as this one, but it doesn't have the length of it. This one here is, this case, another inch longer. It comes out here. Okay, so this has a 4 1/4 bore cylinder that bolts right onto it. I want to get up to about like a 4.7 bore motor for my other motor. It was going to be this one, but not no more. So I wanted to see how big of a boss I need to weld on the case to make it what I need. Okay, this motor here, it needs to grow a little bit because this is 3 7/8 bore motor and it needs to go 4 1/4. So we need to put this cylinder onto this motor. So obviously, when you go to do that, you have no room for the head bolts. Or not the base nuts. They're gone. Studs. Studs are being covered up. So the front of the boss to the back of the boss is tall enough. We got that. The width is too narrow. And we're seeing that right over here. This boss is like I said, it's about 5 1/4. This one here is quite a bit more. It's almost 5 1/2, 5.4. So it's easily more than this one is. The difference is in the width. This one here was almost 6 inches. It's like 5 and we'll call it 4 and 3, 5 3/4. We'll call it that. This one over here is only 5 inch. So we need to gain this 3/4 of an inch to equalize what this one is, to be the same width thicknesses. Now this case here is, let's see, it's a 1/2 inch scale. We're not quite a 1/2 inch thick. This one here is basically about a 1/2 inch thick. So this one's just a tick narrower than this one. So this side's good. Obviously they went over here. This one here is about 3/4 wide, and this one here, once again, we're about a 1/2 inch thick. So this side is the same size as this one over here. So what all this means is we need to gain some length, or width in this case. The length is fine, the width sucks. So what we're going to do is we're going to put a spacer in here. So people ask me what I call about spacers. That means you put a spacer between the two case halves and spread it apart. So that gives you the increased capacity to run a bigger bore cylinder and not have to do any welding. Just put a spacer in there, machine a spacer, stick in there. Now the cranks have to grow also when you do that. Now this is a generator motor, so this is an alternator snout. So this one already sticks out too far. See how it sticks out way out? See how this one over here, it's buried up in there? So on the seal surface to the spline is 1 3/8 inches. See how this one's almost the same, 1 3/8 inches. Except this motor is made for a 3/8 inch different offset primary. Between early panhead and alternator, it's 3/4 inch difference. When I went to the starter motor in '65 for the generator shovel motors, which is what this is, they moved it over about 2/3 of the way. So they're about 3/8 short from going all the way over. So they went over about a 1/2 inch more than the early motor, but they're about 3/8 inch less than the late motor, roughly. I'd have to go get a look at the main shaft links on the tranny to see for sure what they did, but that's about what happens. So automatically I can put a 3/8 inch spacer right here, and that would equalize the protrusion over here to make it the same thing, theoretically, even though I'm not seeing that right in my measurement right here, because I'm seeing almost the same thing, which is kind of weird. But I'm not sure where the bearing is. I can't get to where the bearing is in here. I have to measure. You need to come off the bearing surface. So anyway, this one here should be move it out quite a bit. The other problem is right now the crank is rubbing on the inside of the case, so it needs to have a little clearance over there. You need at least a 1/16 of an inch. You can run an 1/8 of an inch. So if you take an 1/8 here and 3/8 here, that's a 1/2 inch. So now we're only 1/4 inch less than we need. So we still got to grow another 1/4 inch more than that. So that means you start cutting back on your sprocket dimension here. Now Jim's used to make longer shafts here that were 3/4 inch longer and 1 inch longer, I think. I have 1 3/4, I think. The other thing that they got is you have a pinion shaft over here. It's a 1/4 inch longer. That crank I just had over here, that 5 inch stroke crank I just showed you, that had a 1/4 inch longer pinion shaft. When you go to a big bore motor, you go to a longer pinion shaft. That way the flywheel can be way over here, and all this stuff gets out of the way. See, it gives you material in here for clearance. Now look how much flywheel clearance we got here. See, we got 3/8 of an inch clearance right there, and this one here we got none. So if I put a longer pinion shaft on this side, then I can grow this motor a 1/4 inch more. Boom, we got the number we need, and all of this stuff over here will still work. So that's pretty much what we're looking at doing. Put about a 3/4 spacer in here, maybe 5/8, but something like that. And then I'll juggle the dimensions of the shafts and stuff and shimming and get the crank where it's kind of centers up a little bit. Just crank right now, if you notice, is not quite centered, but pretty close. That's why it's hitting down here, because it's not quite right. I need to move over about another 50 thou, and that would give me my clearance over here that I'm missing. So like I said, you don't have to have this exactly on center. You can be offset a little bit. It's not going to hurt. The bigger the piston is, the less that matters. This motor here, you look, it's on center, but it doesn't have to be. It can be over. It's not going to make that big of a change. Alright, so that's all part of designing a motor. You got to fudge it where you can to make things work. So this motor is probably going to get a 1/4 inch longer pinion shaft, and then this is going to get pushed over here. So I'm going to find me an 80-inch crank, which is basically a 107 motor, is the crank I'm looking for. 107 motor has a 1/4 inch longer crank in it. And it has the 4 1/4 stroke I'm looking for. A 113 has a 4 1/2 stroke, which I'm not looking for. So I gotta go find me a 107 crank, or I'll make one. I'll probably just make it. So that'll do what I need on that one. This crank here is going to come out of here, and it's probably going to wind up going in this motor over here. This motor right now has a twin cam crank stuffed in there, which is a 4-inch stroke. And you can see how the piston's a little short over here. Doesn't quite go up all the way. So that's because I had it spaced up where this was hitting the flywheel down here. So I gotta see how much longer this is than the other one. I'm not sure exactly what this motor is buried in here. I never had these dimensions before to work with, so I think this is a 63 panhead case. Okay, this deck height looks like it's going to be pretty close to 5-inch. And I think we already determined that this one was 5 1/8, wasn't it? Nope, coming off here we are not. We're about 4 3/4. Or 5 3/4, excuse me. No, what do we got? 4 3/4. I'll get that right. 4 3/4. So this is a little bit taller deck than that one over there. Is where this one's going to be made to be at. So it looks like this is going to grow up anyway further yet, and we're going to go to a bigger bore. Like I said, this is only a 4-inch bore motor, but it was a fuel motor, so it's really thick. It's 1/4 inch wall cylinder sleeve, see? So this easily could be a 4 1/4 motor with the same spigot diameter here. Excuse me. So you can see how thin it would be right here on that side. And this side over here, see how thin it is. So this motor's going to have to grow another inch in width than this one. So it needs to be up to this width here. We're on a 4.7 bore, which would be 300 right here. That'd be 4.7 bore, that wide. So that would leave almost a 1/2 inch, not quite a 1/2 inch thickness here. A little under 3/8 7/16. So it'd be like what this is. So anyway, that gives you an idea what has to be done. We're not going to run as tall as this, but we can get it. We're going to be up there though. Alright, so that's what I'm going to do on that motor. These other motors are going to do some other stuff too. Alright, so I got some basic ideas in my head what has to be done, so I'm going to go ahead and get this apart and do that. So let me get this out of my way, I'll be back.